Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals. And here we are going to discuss this problem in which we are given a function f which is from open interval 0 comma infinity to the set of real numbers, and we have a function g of x that is equal to integral 0 to x f of t dt. And further we are given that g of x square is equal to x square times 1 plus x. Then we have to find out the value of f of 9. So now to solve this problem, we have to make use of the fundamental theorem of integral calculus. And fundamental theorem of integral calculus says that if we have a function, say a of x, which is equal to the integral a to x, and we have f of t dt, then the derivative of a of x, that is a prime of x, is equal to f of x, right? Where this function f of x is a continuous function in the interval that is closed interval a comma b, and this point x, it lies between a and b, right? So we are going to use this statement to solve this problem. So here we are given that g of x is equal to the integral 0 to x f of t dt. So now if we differentiate both sides, that is d by dx of g of x, then we have d by dx of the integral 0 to x f of t dt, right? So here we have seen that when we differentiate both sides, that is d by dx of a of x, then we get a prime of x. And here when we find d by dx of the integral from a to x f of t dt, then we get f of x, right? So replacing this t by x. Okay, so here we have d by dx of g of x, so the g prime of x is equal to f of x, right? So we have g prime of x is equal to f of x. Now let us consider this equation, that is g of x square is equal to x square times 1 plus x, which can be written as x square plus x cube. So now differentiating both sides with respect to x, we have d by dx of g of x square, and here we have d by dx of x square plus x cube. So the derivative of g of x square is g prime of x square, and by chain rule the derivative of x square is 2x, and here the derivative of x square is 2x, and here the derivative of x cube is 3x square. So now we have 2x g prime of x square, and here we have 2x plus 3x square. Now taking x common from these two terms, we have x, and here we have 2 plus 3x. Now we can cancel this x with this x, because here x belongs to the interval 0 to infinity, and x is not equal to 0. So we have now 2 times g prime of x square is equal to 2 plus 3x. So g prime of x square is equal to 2 plus 3x divided by 2. So now this is a functional equation, that is g prime of x square is equal to 2 plus 3x over 2. So let us replace x square by some other variable, say y. So we can now write g prime of y, and here we have 2 plus 3x. Now when we are replacing x square by y, it implies that we have to take x is equal to square root of y. So here we have square root of y, and here in the denominator we have 2. So we can now write g prime of y is equal to 1 plus 3 over 2 times square root of y. So again changing the variable from y to x, that is the usual notation. So we have g prime of x is equal to 1 plus 3 over 2 times square root of x. Now g prime of x is equal to f of x. So replacing g prime of x by f of x, we can now write f of x is equal to 1 plus 3 over 2 times square root of x. So this is our function f of x. So we have find out the value of f of x. So now we can easily calculate the value of f of 9. So f of 9 can be obtained by replacing this x by 9. So we have 1 plus 3 over 2 times square root of 9. Now here we can write 1 plus 3 over 2, and square root of 9 can be taken as plus minus 3. So taking the square root of 9 as plus minus 3, and now taking first taking the positive sign, we have f of 9 is equal to 1 plus 3 over 2 times positive 3. So we have 1 plus 9 over 2, that is 2 plus 9 over 2, that is 11 over 2. So f of 9 is equal to 11 over 2 when we have the positive square root, that is plus 3. Now taking the negative square root, so we have f of 9 is equal to 1 plus 3 over 2, and here we have minus 3. So this is 1 minus 9 over 2, that is 2 minus 9 over 2. Here we can write 2 minus 9 over 2. So f of 9 is equal to minus 7 over 2. So here we have obtained two values of f of 9. The first one is 11 over 2, and the second one is minus 7 over 2. So 11 over 2 is corresponding to the positive square root, that is plus 3, and minus 7 over 2 is corresponding to the negative square root, that is minus 3.